Good morning, and thank you so much for joining us today for our webinar, What's an IoT Deep Dive? The Anatomy of an IoT Solution. My name is Chanakya Lokam. I'm the Director for Innovation at Miracle, and I will be your speaker for today. So a quick look at the agenda of the webinar today. I'll quickly give you a brief overview of Miracle's introduction, and then we'll talk a bit about how the industry and the overall enterprise is changing with the interjection of the Internet of Things. After that, we'll be talking a bit about how a regular IoT solution would look like from end to end, what sort of components you would have to think about, and what sort of needs you would have to look into when you're trying to implement an IoT solution. After that, we'll be looking into some of the use cases that Miracle's team has worked on in the past, and maybe that'll trigger some ideas for yourself as well. Before I go into the live demo, I'll also be talking a bit about how you can engage with Miracle for any of the use cases that you have, and I'll also be showing a quick demo of the What's an IoT Platform, which is from IBM, and how you can connect your devices to that platform. At the end of the webinar, we'll open it up for question and answers, where you can post your questions either in the right-hand side chat panel, or you can click the raise hand button in the right-hand side chat panel as well to ask your questions. So let's deep dive. Miracle is a global systems integrator. We've been an IBM partner for over 15 years now. We're headquartered in Novi, Michigan, but have offices across the United States in Atlanta, Cincinnati, and Arkansas as well. And we also have global delivery centers in the United States, Canada, and India as well. One of the main motivations behind Miracle and our deep expertise within spaces like cloud, IoT, and others is the fact that we implement something called affordable innovation. And we constantly remind our customers of the importance of being able to innovate and disrupt their markets using technology. We feel that while quality and technical expertise is very important for our customers, it's also very important for them to be able to innovate every day, and not as a luxury, but more as an affordable commodity. And that's what we provide through our hybrid delivery model. Our technology expertise includes expertise across building custom applications, whether it's on-prem, legacy systems, cloud, microservices. We also do a lot of work around ERP support in terms of SAP, Oracle, and Microsoft. One of the niche areas that we work in would be the integration space, whether it's cloud integration, API economy, or business integration. And we also do a lot of work around quality assurance, quality engineering, and the overall DevOps cycle. We work across multiple industry verticals. We're not limited to this, but these are some of our major verticals, and especially the manufacturing, energy and utilities, logistics, healthcare, retail. These 5 industries, I would say, are some of the booming industries in terms of where IoT is being seen as coming into the industrial side. We're seeing a lot of new companies look at IoT as a very big differentiator for them as they move forward. As I said, we hold strategic partnerships with multiple different IT giants, such as IBM, Oracle, Microsoft, and SAP as well. So as I said, our technical expertise spans across the overall infrastructure space, whether it's information management, data management, or application management. We do a lot of work around the integration space in terms of integrating your different systems, whether it's to the systems engagement or through the systems of record or systems of insight with data integration as well. And we also do quite some work around the engagement areas, so systems of engagement in terms of creating mobile apps, whether you're trying to create cognitive and connected apps with the Internet of Things, or if you're trying to create digital experience and commerce portals for your customers as well. So once we go into IoT, one of the things that we keep saying at Miracle is that IoT is not one technology that solves one particular use case. It's a combination of multiple technologies, multiple devices, and multiple ideas that solves anything that you want to be solved. The possibilities of what you can do with the Internet of Things is limitless. And as we're seeing it, there's 2 major phenoms that are happening right as we speak, and that's the emergence of technologies around both the connected solutions, which is the Internet of Things, and also cognitive solutions, which include machine learning, natural language processing, and overall cognitive and artificial intelligence capabilities. The market share of both of those together is estimated to be over $600 billion by 2020, which is going to be a very, very large growth from where we are today, with the expectation of almost 50 billion connected devices by the end of 2020. As you can see, right now we're in that phase where IoT has become mainstream. It's become a differentiator for enterprises. At the same time, we're seeing a lot of IoT products coming into overall consumer automation, home automation, in terms of how consumers are interacting with their devices at their home or in their car. The next wave that we're looking at as we move forward, if you can see the 2016-2017 charts, we can see more of this automation happening in the industrial sector, whether it's your SCADA systems that you're connecting, or you're trying to connect devices that are being used in your plants, whether it's predictive maintenance or consumer experience. We're seeing a lot of different possibilities coming in, and data is going to be very important in terms of where this data is coming to and how you're able to actually control your devices. So both of those possibilities are going to be very important as we move towards that all-important 2020 mark. So as I was saying, the possibilities are limitless once you come into this new age of connected devices and connected things. It's not just people that are connected to the internet, it's everything is connected to everything. So it's a network of all these devices that are interacting with each other to make sure that our lives become easier. One great example would be your refrigerator being able to detect if there was enough milk in your fridge or not by communicating with the milk carton, and then the refrigerator being able to communicate back to your car saying that you do not have enough milk, your car interacting with your mobile device telling you that you don't have enough milk, you interacting back with the mobile device telling the car to take you to the nearest store to buy milk, and then the car actually being able to speak with the retail store to be able to order milk for you, communicate also with your payment system to know which credit card you want to use based on your preference of the past, and then make that payment, have the milk ready by the time you're there at the retail store, pick it up, and then you come back home. So the way that the experience of your consumer is changing is going to be very important with the Internet of Things. But that is just one possibility out of an infinite loop. And the number of possibilities around the industrial sector are even more, as we can see various customers looking at how they can automate their systems, or how they can automate their devices at the edge in these manufacturing plants and other warehouses that they have today. So as we look at the limitless possibilities, the first question that will come up is, so what do I have to do to implement an actual IoT solution? What are the different components that I need, and how do they work with whatever I have that is already existent today, whether it's a record of customers or if I have a set of APIs? How do my applications actually interact with this new age technology that's coming up? So there's a lot of different components that sit within an IoT. Going to be your end user applications and the end smart devices. Now, a lot of customers might already have some of these, but they might not have what is there in between of the whole anatomy of the solution. A lot of customers already have SCADA devices in their manufacturing plants. They might already have an OBD dongle in the cars that they sell, or the parts that they sell to those cars, and they already might have smart devices that are available for these customers. So what is it that they have to do to enable this? A lot of times the first connectivity mechanism would be, how do you connect these devices back to the internet, or how do you communicate with the external world? And a lot of times we're seeing that they're communicating via either a field gateway, like something like a mobile device, or an actual embedded gateway, which could be anything from a Raspberry Pi to a Dell 5000 series IoT gateway, which would give you all the capability and ruggedness that you need in an industrial scenario. The connectivity that occurs between these smart devices and the gateways is usually via either a local network. It could be you could create a mesh network for security reasons. There's also communication with a lot of these gateways over something like Zigbee, which is a new age protocol for device communication for mesh networks. You can also use existing protocols such as CAN bus and Modbus as well to ensure that you can connect your devices to your gateway. So the connectivity mechanism would be up to you, but you would have to connect it. A lot of the new age devices are coming with Wi-Fi enabled. If it's smaller, they're usually coming enabled with BLE, which is Bluetooth Low Energy. But there always is a connection mechanism to send your data from all these networks of sensors or devices over to a smarter edge gateway or edge device. Once the data comes into this edge gateway via one of those protocols, the number one protocol that's being used today to publish and subscribe messages to the cloud or wherever your broker is sitting is MQTT. It's in its third version, and it's become very, very popular today in terms of being used in the MQTT space. There's a lot of different providers that are providing brokers out there, but there's a lot more than just the broker in terms of sending and getting back messages. You also have to have an ecosystem around that broker in terms of being able to create your applications, being able to interact with these devices using regular REST technology in terms of APIs, so that your developers don't have to actually adopt new programming skills around being able to use MQTT clients. You could still use that, but the better way would be to use built-in APIs and SDK kits that actually map around these MQTT protocols to be able to give you actual HTTP REST APIs. And that's something that the Watson IoT platform provides to you for you to be able to integrate device data and also device commands in your applications that you have today. On top of that, you would obviously have your end user applications. Some other things that this cloud gateway provides along with the MQTT broker and SDKs would be something like a rules engine, where you could say if this is the value that's coming in, do this. You could create triggers. It's also very good to always have some sort of data flow or data wiring tool. Watson IoT provides both of those in terms of a rules engine and also something open source like Node-RED to be able to really route your data as you wish. Once you have your data, you could either put it in an end user application or in one of your data lakes or your data stores, and that's where post the data coming in, that's where you can do a lot of stuff on this data that's there at rest. You obviously would do a lot of analytics at the edge. You would do a lot of analytics while it's in the stream. But you would also like to do a lot of batch analytics in terms of once it's at rest in your data lakes. And that would include doing stuff like predictive maintenance, predictive analytics, machine learning, and also being able to use this data in terms of dashboarding it for your users to be able to gain insights into your business as well. So taking that same architecture over to the Watson IoT platform, you can see how it's assembled in a very similar way. You have your device or your gateway at the edge, which would be connecting to the IBM Internet of Things Foundation, which is now called the IBM Watson IoT platform via MQTT. And then from there, it would be exposed to your applications and your data stores using these REST APIs. This is a simple architecture diagram of a recent use case that we built, and this was basically being able to control the lights at home over MQTT, which would mean that you would be sending all your commands to these lights, not directly to the lights because of the lack of connectivity to them, but you would be sending them to the cloud, which is the Watson IoT platform, and the Watson IoT platform would actually take whatever data is coming in terms of commands and publish that to the devices as a command using MQTT. In this case, we use the Raspberry Pi as a gateway. The Raspberry Pi would actually be able to listen to these commands, subscribe to them, pull the commands from the cloud, parse them, and interact with the light using technologies such as Zigbee. In this particular case, we actually used HTTP to connect and communicate with the lights. But you could use something like Zigbee to communicate with the lights and make sure that they understand the command, and then relay back the message or publish the message back to the Watson IoT platform saying that, yes, the light was turned on or the light was turned off. So some of the use cases that we're seeing out there, as I said, there's a lot of use cases that are already there. But first of all, what do you actually want to do with all this IoT data or all these devices that are getting connected? There's multiple use cases. One would be obviously to be able to take this data and predict outcomes, do stuff like predictive maintenance for your customers so that they can actually have a better end user experience with your devices or whatever product you're selling to them. You could also monetize this data like the weather company does. It takes all its IoT data that it's collecting and actually provides a set of REST APIs that you can use. You can also extend these APIs and these dashboards to your developers to be able to integrate and build better user experiences for your customers and existing applications using all this data that's out there. And one more use case that's really coming up big is being able to actually control these devices. It's not only about bringing data back to the cloud, it's also being able to send back data to these devices to be able to control what's happening with your device. So this is a quick use case of what we built for a cold storage facility. And basically what we did is we used a set of Texas Instruments sensor tags, which have both humidity and temperature sensors within them. And we used a BeagleBone Black as the gateway within that cold storage facility. And we were doing constant monitoring of the temperature and humidity values of that facility and sending all those messages back to the IBM IoT Cloud. We were then using Node-RED to do both check the values and also stream this data back into a NoSQL database, which is clouded. We did bucketing model within Cloud to make sure that the NoSQL data is stored in a document per day. That's the model that we chose over there. But we also ensured that whoever the manager was could receive alerts both via Twitter and also via Twilio through Node-RED. So if there was a drop in temperature or there was an increase in the humidity, the facility manager would immediately be informed of that particular status via multiple channels. The facility manager would also have the capability to actually be able to go into his mobile app and be able to control both the temperature and humidity through the thermostat that's available in that cold storage facility. One more use case would be using OBD. For those of you who are new to OBD, OBD is onboard diagnostics, and it's actually the standard mechanism that exposes values like fuel consumption, distance. It also gives you a lot of different data points, such as the status of the handbags and other sorts. And this is common for all cars and all vehicles that were manufactured after the 2000s. And since then, OBD has been there. OBD is now at OBD2 standard. And you can actually plug in a dongle into your car today and actually be able to get that data out to the cloud. In this particular case, we were getting all that data into a field gateway, and that was relaying it back to the cloud for analytics on top of that data. One more use case was for lawnmowers, and basically this was a predictive management maintenance use case where all the data from the lawnmowers, from its engine control unit, was being relayed back to the cloud, and that was being exposed into IBM's integration bus using a REST API layer, where real-time data was coming in, and operational decision management was used to actually verify what the values of the data were, and alert the user based on any anomalies that were seen in the data. So as a next step, I'll quickly show you kind of a brief overview of the Watson IoT platform and what it looks like to work with it. So the screen that you're looking at right now is the Watson IoT platform dashboard. Let me actually go to my actual dashboard. So the first feature that I wanted to show you is connecting your devices. So if I go into the device tab, you can see that I currently have 3 devices connected, but only one of them is connected to the network. You can add any number of devices, and the way that you add it is you add a device type, and then you group together devices into that device type. You can see that I have RPi, BeagleBone, and Arduino device types that are connected to the cloud. You can connect also various systems using the APIs that the Watson IoT platform has. Watson IoT platform also has APIs for device registration as well. So if you don't want to, if you're trying to create a consumer product that connects to the cloud automatically or dynamically, you don't have to register the device beforehand in the Watson IoT dashboard over here. You can actually enable your device to connect using user credentials when it comes online. So whenever a user opens up their device and connects it at home, you could trigger an API call which would register the device in real time dynamically and actually register itself into this dashboard so that you still have the data in the dashboard, but you also have it available. At the same time, you don't have to use this dashboard for visualizing the data as well. You can, again, use the APIs to store the data into your database and use your own business intelligence tools that you already have today for analytics to showcase that data. Once you have the device type, you'd basically give various information in terms of what the device metadata is, what sort of security you want to use on the device. The IBM Watson IoT platform by default gives you authentication tokens, which are basically used to handshake between the device and the cloud gateway, which is the Watson IoT platform. So whenever a device tries to connect to the platform and send MQTT messages, it's going to have to authenticate itself using those security tokens that it has or gets during registration. So once you have your devices, you can actually do a lot of different things on top of it. One of the things that you can do is you can actually authorize apps to be able to use the APIs of the Watson IoT platform in your organization. So all the devices that you have, let's say suppose you wanted to give an application permissions to use the API to actually send device commands to all the Raspberry Pis that I have connected to the Watson IoT platform. You could come in here and create a new API key and give that API key to the developer to be able to actually create applications using that API endpoint. One more thing that you can do is you can visualize data in terms of summaries over here. So I have a quick demo board that I created. And you can see that right now the BeagleBone accelerometer is not coming. All this data is for the sensor tag. But I can quickly go in here and add a new card. And let's call it generic visualization. And we'll use it from the Arduino. And we'll connect a new data set. We'll want the temperature to come in. And we'll call it temperature. We'll leave it a float. Next. And we'll say, just show it to me as a pie chart. Next. And submit. And you can see this is a new chart that we just created, and it's actually coming. This is real-time data that's coming in. This is the temperature of the Arduino that's coming in over here. Since there's not a lot of variation in terms of the temperature that comes in for the Arduino, you're not going to see a lot of difference in the values over there, but that's real-time data that's coming in. And if you want to see the status of your device and what events are coming in, you can actually click on the Arduino or the device over there, and you can go and see the device events that are coming in. And if I click on the event, I can actually see the value that's coming in. You can see that there's a name that's coming in, and there's also temperature that's coming in for the device as well. So the last thing that I wanted to show would be the rule engine, where you can actually create rules on top of devices. So I'm going to go ahead and create a quick cloud rule over here. So we're going to call Arduino temp rule. Triggers alert, and we'll say it applies to the Arduino, and we'll click on next. And here you can see you can actually create conditions that have to be triggered, and then the action that will actually get triggered when the particular condition happens. So we can actually select a property, go in here, and we'll select the property as temperature, and we'll see whenever the temperature is greater than 30, since that is the value that seems to be coming. You can actually also compare it with different properties. So if there's two different properties that are coming in and you want to compare one against the other from the device data, you can do that as well. In this case, I'm giving it static value as 30. And you can give it a new action. And there's multiple different actions that you can configure over here. So you can see you can send an email. You can trigger an if action, which is if this then that. You can trigger a webhook, or you can trigger a Node-RED flow as well. In this particular case, we're going to go ahead and do send email. Actually, let's go ahead and do send Node-RED, trigger Node-RED flow on temp alert. description triggers Node-RED. And click next. So it's going to ask you for the Node-RED URL. So for that, let's go back into my Bluemix dashboard and open up Node-RED. So you can go into your applications, and you can see the Watson IoT demo. I'm going to click on this. Oh, let me start the application. So while it's starting, we'll go back over to our dashboard and we'll configure the rest of the ones. In this particular case, we're not going to need a username or password since we're not going to protect the API with a username or password. But we will give the URL. And this is basically the body of the data that's going to be sent over to Node-RED when that particular condition is triggered. So our Node-RED is up. Let me refresh this. So yep, our app is up and running, and Node-RED is up. So this is a quick IoT flow that I already have that's there. I'm just going to go in here, and let's take this. And let's configure this to be post. Yep. So basically what this is going to do is it's going to create an alert message and then print that payload. Actually, we can just go ahead and create a new one if we want. So we're going to put a HTTP endpoint over here. We'll call endpoint as post. We'll call it /trigger. So it's basically going to be /trigger plus this. So we'll take that as the URL. We'll configure it over here. We'll click finish. Looks like there was there's two slashes over there. Let's just remove that. Click finish. And that action was created. So we'll add that action, hit OK. Come back here, and we'll call trigger low on temperature. And we're basically going to just put a debug node over here to debug the payload every time it's triggered. So with that being done over there, we can go ahead and activate the rule. And now that the rule is activated, it should already started. But let's just try the URL for ourselves as well. So it's not a get. Let me open up Postman. We'll do a new post. Enter body raw. Content type application/JSON. This is just a test run that I'm doing for the API to make sure that looks like that URL did not work. So it looks like there's a problem with that, so we'll change this action over and we'll call it the send email instead, and we'll configure it to send it to my email address, and we'll say include the data as well. Finish, and we'll save it once again. And this should give me a lot of different data that's coming in. So I'll go back to the board, and temperature does seem to be coming over 30. There aren't any rules that are getting generated. Let's see. Temperature is 37.5, which means that there might be error within the rule. So let's go back to the rule. Temperature is greater than 30. Let's go ahead and add a new card. Give me a quick second to just debug this. Looks like there's some problem with the demo. Temperature is greater than, let's go less than 50 then. Let's see if that'll work. Okay. So it looks like somehow the rule is not being triggered, but when it is triggered, there will be data that will come over. I apologize for the inconvenience, but due to time, we're going to have to wrap up. So just to wrap up, you can engage with any of the Miracle's IoT teams for your IoT implementations. We start off in a 4-stage process. We can start off with discussing with you in terms of design sessions, and also looking at the overall strategy that you need, and then kind of try to map in the second step what you need for your IoT solution in terms of technology and the scope of a POC. The next one would be to actually implement a POC to see the feasibility of the technology and the cost as well, and then actually extend that POC into production. So the life cycle of POC is usually establishing what devices you need, establishing the requirements of the POC, making sure that it's feasible, even theoretically, in terms of device capabilities and cost feasibility. And then actually looking at the different components and the platforms that you want to use, and then start building around that, and look at the data protocols in terms of how data is going to be integrated and how data is going to be streamed into your platform as well. The final step would be to actually look at how you can actually operationalize and consumerize or productize this POC and then scale it up for your consumers. With that being said, let me open it up for Q&A. If there's any questions, we might be able to take 1 or 2 questions. Looks like we don't have any questions for today. So with that being said, let me thank you for your time today. One more thing that we need to mention would be our Bring IoT Home workshops. If you're looking for some exposure in terms of connecting devices to the Watson IoT platform or any other IoT platform, Miracle would be more than happy to come over and deliver free workshops for group sizes of 15 to 30 developers. Where we would come in with IoT kits, give them to your developers, and actually have them hands-on connect them to the cloud. The complete workshop would be hands-on. It will be for about 6 hours. So we start off at 9 o'clock in the morning. We should be able to complete by 2 o'clock or 3 o'clock. It will give a great exposure to your developers in terms of how to use the platform and how to actually build an IoT solution. We also have a lot more webinars coming through. Join us again on December 15th, where our data experts will be talking about Cognos BI and how you can actually utilize it to extend the value for your enterprise. Finally, Miracle can help you a lot with your digital transformation needs, whether it's doing a digital transform workshop, design sessions, extending our labs and COA ecosystem for your pilots, and also doing a lot of health check workshops around modernization from your legacy systems to your enterprise next-gen systems as well. With that being said, let me thank you once again for joining us. Thank you for your patience for today's webinar. We apologize for any inconvenience created at the start of the webinar. And stay tuned for more webinars from Miracle. And thank you so much for joining us today.